Hey everybody, how are we doing? We got Josephine here, Vincent, and Tiffany. You bet. We got some Canvas content. Go over the startup company question. Yeah, of course. Tiffany's got the first question here. Vincent, if you clarify yours, you've got the second. Josephine's got the third. Madison, you got the fourth. We got questions ready to go. Mubot's giving out 100 points in the chat. The one with the organization monitors, you bet. So we can do the organization monitors coming up here second. Let's go hop in. We've got some 2 sample means to start. Some 2 sample means. Tiffany, yeah, doing great. Great work on the visualization there. Everyone's doing some great work, practicing the material. Really comes down to the end of this class, just practicing the material. Chill music on. Any piano music. I need to download more YouTube music. All this music is thanks to YouTube giving me music I can play that people have said, you can use my music on YouTube and not get copyright claimed like The Rock. He didn't copyright claim us yesterday in the second class. Let's go check out some hot dog questions. I'm doing great today. And here we are, meat versus beef hot dogs. Let's check it out. Okay, so with this question right here, we're comparing the means of 2 groups. So we are comparing the means of meat hot dogs, how much fat they have, and beef hot dogs. Yes, Ashley. Talk to an advisor, and there are drops sometimes. Ashley, great to having 320. Also, I teach 320, and if you don't get into my section, I do hold office hours like this right here. And we do activities online nowadays, so you might see those BS 320 activity videos. Check those out. No matter what, I'll be there to help out. And we got the Discord, so even if you don't get in my section, we'll have tons of help for BAS 320. You got this. And Michael, you bet, we'll be doing that here in a little bit. We can do the congenital abnormalities. So with this question right here, this is 2 means. This is chapter 17, 2 means. And what do we have going on? So you go to the hot dog factory and you go, there's our list of our companies, and you grab a bunch of meat or beef hot dogs. I don't know why these packages are labeled. So you got a bunch of packages of meat hot dogs and a bunch of packages of beef hot dogs. Now, the question doesn't say this, but the difference between these hot dogs looks to be about, this one might have, let me see, beef minus meat, and the interval is negative. So if the interval is negative, the second one got it. So this is the meat right here, and this is the beef. And I'll tell you how I'm able to figure this stuff out here with the intervals that are given. Awesome. Thank you so much, Ashley. And so what we have right here is the meat would need to have something like 13.6 grams of fat on average. So the mean for this group, mean for meat is equal to 13.6 grams. This problem doesn't say this, so I'm coming up with numbers that would work theoretically with the problem. And the mean for beef is equal to 10.0 grams. So can anyone tell me what is the mathematical difference right here? So it doesn't give this, but I'm able to like come up with a similar, like the way it would work. What is the mathematical difference between the beef hot dogs mean? Like you take these hot dogs, you take these pats of hot dogs right here, hot dogs, and you say, let me find out the average grams of fat in the hot dogs. For the beef, there was a mean of 10. For the meat, there was a mean of 13.6. So what is the difference between these? What is the difference between these 2 means right here? So you take these 2 means right here and you say, what is the difference between these? So you look at these 2 means and you ask yourself, well, what is the difference between the beef and the mean hot dogs means? So like you have beef hot dogs had an average fat content of 10 and meat hot dogs had an average fat content of 13.6. So what would be the difference right here between these? 3.6 exactly. And oh no, I did the numbers wrong. So 3.6 with my example. My brain is still okay. Now my brain's working. Mathematically, this should be 3.8. And the reason it should be 3.8 is that's at the center of the interval right here. 3.8 is at the center of this interval. Our interval up top, sorry, my brain didn't work, could be written as negative 3.8 plus or minus. And so what is the plus or minus on this interval? Look up at the interval up top. It could be written as negative 3.8 plus or minus what? And this is the uncertainty. This is the margin of error. So think about 3.8 plus or minus what? Yeah. You bet, Kevin. We got a few questions lined up, but we should definitely be able to get to that. We'll make sure to do that since that's the first 320 question. You bet, Kevin. We'll probably do that in about 25 minutes. Great job, Tiffany, right there. The margin of error is 0.3 because that's half the length of the interval. You can also confirm to see if you get 4.1 to 3.5. And so what are we talking about right here? We're testing these hot dogs to see what the fat content is. We estimate that the true mean for the meat hot dogs is 13.8. We estimate that the true mean for the beef hot dogs is 10.0. In truth, we're actually collecting sample means. We're trying to estimate the true mean. So we don't know what the true means are, but we're estimating what the true means are, and we're estimating that the difference between them is 3.8 and plus or minus 0.3. Now, what does it mean that the difference is negative? Think about this. The bigger number is on the second side. So I think it asks questions. The endpoints of the confidence intervals are negative. What does this indicate? So that would mean we are fairly certain what? Just talk to me. With the interval being negative, we'd be fairly certain which of these has more fat content. Might be. Your interval looks to be wider. My interval's tighter. It could be. And so since your interval is maybe completely positive, if your interval is positive, then the beef hot dogs would have more. Because your interval must be something like, it must be that the beef hot dogs have more, like it must be positive numbers. Be careful. My interval is negative, which means the meat hot dogs have more. Does that make sense? Oh, if your interval is negative, then it would be that the meat hot dogs have more. Does that make sense? Because if you do 10 minus 13.8, what does this mathematically solve to? If you do 10 minus 13.8, what does 10 minus 13.8 equal to? It equals to negative 3.8, and that indicates the beef hot dogs have more. And then the margin of error right here, since it's completely negative, we would say that we're pretty confident that the beef hot dogs have more. And your interval is completely negative too, which is an indication of we believe that the meat hot dogs have more fat content. The second mean being bigger as far as we can expect. I am clicking in here and it's selecting answers. The mean fat for the is probably higher for the meat. The mean fat is probably higher for the meat. That one. What does the confidence interval does not include zero mean? So think about this. We think that the true difference between these hot dogs is probably somewhere between 4.1 to 3.5, which means we think there is a difference. That it could be that the meat hot dogs have up to 3.5 more grams of fat or up to 4.1 more grams of fat. And so the difference is statistically significant. So it is statistically significant. The difference in the two samples is statistically significant. Now, this is a great question right here. It's asking, we did a 99% confidence interval. With 99% confidence, there's a simple formula to figure out the alpha for the two-tailed test. To find the alpha for the two-tailed test, so there's a good note to have, a confidence interval looks like this. But a two-tailed test looks like this. So if we had 99% confidence like mine, then what would the alpha be? With 99% confidence, what is the alpha? Now, not the individual, but what is the overall alpha for the two-tailed test with 99% confidence? Is it a question? Yeah, Kayla, actually, and Dr. Petrie wanted me to mention the Milton stuff to you because I have a lot of questions lined up. Yeah, that'd be awesome. And I've got Milton updates for you and stuff like that too. So I've got a lot of good news on those fronts. So we should talk about that. No, Kayla, that's awesome. Yeah, we should hop on Discord and talk about that. Because that'd be great. No, I've got a lot of good news. So we should jump on like a Discord call or something like that and talk about that stuff. That'd be awesome. And great work, Kayla. I'll share with you all the information. Like, put it this way, Dr. Petrie said he's very impressed with you. He's like very impressed. And he's like, yeah. A lot of good news on that front. For once, good news, right? So we got some good news on that front. So if there's 99% confidence, awesome. Probably later tonight, I think. With 99% confidence, what would be the remaining outside? What would be the remaining outside? We got Christmas colors on the screen right now. If we have 99% on the inside, what would be the remaining outside? Oh no, but he kind of said that too, and he was like, even though just 2 conversations, he's like still super impressed. That's like his words. Like, it's like I've talked to her like twice, and I'm super impressed. Yeah, I think it's fine to share. 1%, great job, Tiffany. 100 points right there. So much positivity. So yeah, no, that's his words. It was a great email. I was like, awesome. No, it was very good news. And I got that email. I was like, yeah, it's good stuff. 1%. So does this make sense? If yours says like 95, what would the alpha level be for 95% confidence? I'm still on top chat. What would the alpha level be for 95% confidence? Like this question changes. It might say 95. It might say 98. And then the two-tailed test is always what to the confidence level. Like if we say 99% confident, the two-tailed test relative to it would be 1% alpha. If we say 95, the two-tailed test would be 5%. So whatever it says, you just do 1 minus it. So if it says 99% confidence, the outside of it is just the remaining portion, and that'll be it right there. So the two-tailed test, if you think about the inside, 99% inside, 1% outside, 95% inside, 5% outside. And just remember the answer to this one, the relative alpha level to a confidence interval is always, so we could put alpha on the two-tailed test is equal to 1 minus confidence level. So your confidence level right there, whatever your confidence level is, 1 minus it. You got it right there. Awesome. So much positivity in the chat. Yep, that's exactly how it works, Tiffany. If it says 98% confident, then the relative alpha level would be a 2% alpha level for the two-tailed test. Because I think with confidence intervals, it's the inside. Two-tails test, it's the outside. So it's just the way it's graphically drawn right there. Confidence interval inside, 99% in the inside. Relative test would be 1% outside. Great stuff. Let's head back to another question. Got all these questions lined up. Let's do it right here. Next question. Vincent has the next one. Thank you so much, Vincent. Can we go over... How do we lose Tiffany? It took your question at the top, Tiffany. Can we go over... Vincent wants the organization monitors. Chapter 15 and organization monitors. And I tell you, like, Kayla, you are the genesis of, like, everybody raising their game because dashboards are the new thing in BAS 475. A lot of people making amazing dashboards. We've upped the game from what we were doing over the summer. Like, but no, Kayla, they're trying to compete. They're trying to compete. You've set a very high bar, so we're proud of that. And that's what we try to do. We try to all work together and learn from each other. Oh, this is homework due tonight. Chapter 15, homework due tonight. Let's go check it out. Here we go. I know the dashboards are so much better. Yeah, that's awesome. Great job. Yeah, because top tier, Caleb. I'm very impressed, and people are doing some great stuff. It probably would be, I think so, because your numbers were the same as mine. Your numbers were the same as mine. And organization monitors. We got it. Here we go. In organization monitors. Let's go do it here. In organization monitors, the aspect of elementary school. I have all questions. That's why I have to know like the start of it. In organization monitors, elementary school education. And they're going to see if students are doing well in school. And they're going to see if they're attending school. So let's grab the question. I'm not using Epic Pen today because it's been causing weird issues on my computer. We'll go back to Epic Pen eventually. So when we do this question right here, the first thing we need to do is notation. The very first thing we need to do is notation. Help me out. I need some notation right here. We have 8,294 students who were randomly selected. From that 8,294, the figure of perfect attendance was this from the sample. Previously in years, it had been 32%. And we want to see if there is any change to this. We want to see if there's any change. Do these figures give evidence of a change? So please tell me any of the notation right here. I think we have all the notation marks. Start me off with some notation. School dropout, you bet, Riley. Yep, you bet. Thank you so much. Got a lot of questions lined up. Love it. The data shows the sugar. We can probably do that. We might. We'll be kind of close, Tiffany, but we'll try. I'm gonna try to do as many questions as we can. So jump on, answer all the questions. Be like, okay, notation. Practice that notation. We got this notation. What notation do we see up here? I've highlighted the notation. It's your job to now find the notation and say, okay, this is the this is the this, because we can start to solve it. I'll start writing out the equation. Let's put the equation right here that we need. The equation we're going to need is that z is equal to p hat. So we'll need a p hat minus p naught over p naught q naught. We'll need a q naught, and we'll need an n, and we'll square root that. So we'll need all this information right here. Who sees any of this information on the screen right here? Do we have any of this info? Or are we done? We're like, we don't got it. We don't got any of this info. We need to find the sample proportion. We need to find... Oh, yeah. I'd love to. As long as Snea gives me permission, I'll show you Snea's app. It's pretty awesome. Like, I'm very impressed. It's a really cool tennis app. I'll take a look at between classes right here. We need notation. What notation? Oh no, we don't know any of the notation. Help me out. Don't worry. We're all just growing what we do. You won't use the tables. We will give you the numbers. Good question right there, Logan. You won't need the tables. Because a lot of times you just don't use the tables. I'll show you here how we could probably solve all the answers for this question without using the table. But we might show you pictures. Who can help with any of the notation? Even if you say, I don't know, that's a fine answer. So we have 32% from a sample of 8,294, where in previous years it had been 31%. In previous years it was 31%. 31% does not come from a sample. 31% is what we assume is true. So what notation do we have here? What notation do we have? Do we have any sort of notation? The current percent, so we have here a sample of 8,294. And from that sample of 8,294, we saw 32% with perfect attendance. And in previous years, 31% from the sample. 31% from the sample of 8,294. In previous years, it had been 32%. So what notation do we have? Any notation? If you go to this equation right here, you're like, I'm stuck. I don't know what p hat is. P hat is the sample proportion. P naught is the hypothesized true proportion. What we're going to hypothesize is true. Anytime you see that little naught right there, it means hypothesize. And then Q naught is the complement. So P naught and Q naught add up to 1. We're going to start us off here with one bit of that notation. So we need to identify. Let's write down what we need to identify. We need to identify P hat. We need to identify P naught. Q naught. We need to identify N. Any of those things we see up there. Always start by writing your notation. And what do we have? Does anyone know? I'll give it 30 seconds here. Oh, great job, Kayla, crushing it. Oh, you reversed it, Kayla. But it probably because what I said, the 31%, the 31% is from the sample. So I reversed it at one point when I was saying it, and I caught myself. You might have heard me reverse it. The numbers would actually come out really close. Good job, Kayla, right there, earning everyone 100 points. Oh, no, well, that's really close. Basically, yep. Basically there. P naught is the hypothesized and P hat is the sample. So P hat comes from the sample and 31% is what we saw out of the sample size of this. So P hat is the sample proportion. P naught is the hypothesized. And then Q naught is the complement. These two have to add up to 1. So P naught and Q naught are just 1 minus each other. And so don't worry. Like you can always look up these formulas if you haven't done them in a long time and be like, wait, which one's which? And so now we're going to go in here. Thank you so much, Kayla, right there. And so let's solve in here. 0.31 minus 0.32 over square root 0.32 times 0.68 over 8294. And so let's go in here. Snea, you should be super proud. Like when I say it, that's at the top of the class, I mean it. Like, and everyone goes different directions. Everyone does all different things for their apps. And I just love seeing the innovation. A lot of people do a lot of very similar stuff. And I want to see new things. I want people to challenge themselves. So Logan, this is going to answer your question. Watch this. This z-score is going to be about 1.95. And so we take this, negative 1.95. There we go, negative 1.95. That's what the z-score was equal to. So here's the thing. If we gave this to you on a test, you should about know the answer. Now, one thing we didn't do is we didn't identify the alternative. The null hypothesis for this, we would state that the true proportion is equal to the null proportion. The alternative, because we're asking, has it changed? we're going to ask the true proportion is not equal to the null proportion. So when I draw this out right here and I draw where my z-score landed, I have to go to where my z-score landed, and my z-score landed right here. So that's a z of negative 1.95, and I'm going to move it over just a little bit. There we go. And then I'm going to go to the same side on the other side and draw a line just as extreme. And that's just as extreme, and I'm going to shade both sides. The reason we shade both sides of this is because the does not equals alternative points in both directions. So the does not equals is shading both sides. It's the two-sided alternative. If you do less than, you shade to the left of it. So if we had done a less than alternative, we would shade to the right of it. If we did a greater than alternative, we would shade to the right of this point where we landed. But because we have the two-sided alternative, we shade both sides. So the sign of the alternative tells you which way you shade. But here's the important thing, and I'm going to throw 500 points if anyone can take a guess of the p-value for this. So what do you think the p-value is about? And this is why we don't always need applets. And this is how test questions could be phrased. Because this p-value, if we see 1.95, we should have a pretty good guess. 500 points on the line for 1.95. Very close. I mean, if we round up, does it actually round up? We should watch the rounding on it. I wish it rounded up to 1.96. I wish it did. But 1.95, you could guess the p-value for this. This is a very, the way this is drawn, super close to this value. The test, it could give you multiple choice. This would be a very fair test question with multiple choice because there should be a number with 1.95 that should have us very close. 500 points on the line. Who can get what the p-value is going to be? We'll confirm it with the David M. Lane here in a moment, but this is where multiple choice on the test could help us out. Who knows? Any guesses in the chat? I've had the music on. Good, I do have music on. Any guesses here? I'm going to pull up David M. Lane. You could cheat and go to David M. Lane. So David M. Lane will give us the exact answer, but we don't need it. A lot of people say, how would I solve this on the test? Multiple choice. And then we could have you look at it and say, well, what's that going to be about? I'll show the answer. Let's go take it out. So we've done most of the work right here. The null hypothesis is that the true proportion is equal to. The null has the equal sign. The alternative would be that it's not equal to. The conditions are random, 10% is success failure. We do meet all of them. I go into more details on the other ones. Sometimes it calls random the independence, because if it's independent, it's random. Random is independent. The Z statistic was negative 1.95. No one got the 500 points. The p-value is very close to 0.05. It says 3 decimals, but I think we'll get it. If we don't get it, I'm going to round that down. Ah, Michael, yes. Thank you, Michael, right there. Michael, did you put it in the app? I think Michael might went to the app with that exact of an answer. So Michael is confirming the answer right there for us. We'll go look at it in the app and show it's drawn, but we're literally just going to redraw it. Now, when your p-value is less than alpha, you reject the null, and there is evidence. So that's how we were... I was like, that's a very exact answer, Michael. And look how close our answers are. My guess and your answer are very close. We're looking to see, has it changed? So remember, our null and our alternative, we're seeing if there's a change. That's why we're picking change right there. This is only a difference of 1%, so the difference is probably not meaningful. The observation change is quite small, so even though it is statistically significant, it doesn't indicate a big change. And we got it. We got it by guessing it. It was close enough, and there's the exact answer. Let's go show it on the app really quick right here. Once again, we did our own drawing of it. Here's our little sketch of what it should look like. And so Michael gave everyone some 500 points right there. It's great to have Snea just crushing on those points, getting up to the rock star level right there. So we have our drawing of what it should look like. And then we go to the app right here and we go to outside. It already pretty much has it set up. And so Michael put in these numbers and got this right here. That's how Michael, I was like, that's a really exact answer. So when you think about it, we can take guesses of these answers using what we know from the empirical rule. And I was able to guess, well, it's about 5%. And it gave me the answer as correct because it's basically 95 on the inside, 5% on the outside. Think back to the empirical rule and how 95% would be on the inside. If 95% is on the inside, 5% is on the outside. When you get to a z-score of basically 2. And the exact answer is 1.96. So it's even closer to the actual z-score for a 95% confidence interval. So using those techniques right there, good stuff. Let's hop to the next question. Let's do this. I also want to point out that that question we kind of went through and walked through parts of it and did it without the problem. So try doing these questions by looking over what it asks and see if you can solve them. The next question comes from Josephine. Can we go over the Canvas content quiz number 9? Let's do Canvas content quiz number 9. Okay, hopping into it. Canvas content quiz number 9. Oh my gosh. We are so close to the end of the semester. We have less than a month and then like everything's over. Is it next week? When is Thanksgiving? Wow, next week's our like one of our last full weeks of school. Oh my gosh, what is going on? How's the semester ending? Once we get halfway through, it's like a downhill ride. It goes so quick. I can't believe I've taught for like a long time now. Let's go preview it. We'll do one version of this right here. We got a lot lined up. We did some Canvas content the week after next, right? All right, Tiffany, so crazy, right? Oh my gosh. Everyone get ready. Let's do some Canvas content. Here we go. Canvas content quiz number 9. Okay. Let's check it out right here. We did this in a previous office hour, so we'll do one version of it here. But if you want, check out the previous office hours where we did more Canvas content. I think it was yesterday we did it. Maybe. A new diet is being tested. The inventor claims you'll lose 10 pounds. Ooh. On average, after 6 weeks. Highly doubt it's 10 pounds of fat. Don't think that's true. 25 people are randomly picked to try the diet. Researchers are convinced the investigators' claim is exaggerated. Which is the correct set of hypothesis statements? Pretty easy to narrow it down to choices what and what. If we're looking at everything right here, we have A, B, C, and D. If you get to this on the test, you should automatically know the null has the what. The null has the what, because you can narrow this down pretty quickly. And this says the true mean. The null it has to be B or D. Great job, Tiffany, there. Now 100 points. Has to be B or D. The null has the equal sign. Josephine, you're right. So now we know it has to be B or D. We've got a 50-50 shot if we just even guess at it. Well, they want to show... So researchers are concerned that the claims are exaggerated. So the researchers want to show that these claims are exaggerated. To show that the claims are exaggerated, they would want to show that the true mean weight loss is less than... It says mu right there. But that's the true mean weight loss. It's a lot. You have to think about what the notation means. It's saying the true mean weight loss. Like, for everybody who's ever on this diet, on average, these people would lose less than 10 pounds is what the researchers are trying to show. They're trying to show the claims are exaggerated. So exactly less than, because that would be evidence that the claims are exaggerated. So that's what the researchers are trying to show. They're trying to show evidence that claims are exaggerated, and the null is always what they're looking for evidence of. A new diet is being tested. We got this one wrong yesterday, so we're going to... Well, not that we got it wrong. We grabbed the wrong number. We don't get anything wrong here. We grabbed the wrong number when we were solving it, and because of that, we got it wrong. So right here, let's grab the right numbers. Notation, notation, notation. I did it twice, and then the second time I did so quickly. 10 pounds is the claim. The sample mean is 7.5 pounds loss. The standard deviation is 6.5, and the sample size is 25. Someone start us off by just giving us one bit of notation. I just need one bit of notation right here, and I'll even write the equation while you put in one bit of the notation. So try to write one bit of the notation right here. We're going to do y bar minus mu naught over s over square root of n. So that's kind of some hints on what we need. And that's going to equal a t with n minus 1 degrees of freedom. We could even run the t-test. But what is one bit of the notation we need? That's what this will solve for. So what do we have? Usually it's pretty... 7.5 is... That'll be y bar. So that'll be the sample mean, the sample yield. So that'll be a sample mean. Yep. So this right here is y bar. That's the sample mean. There's the sample size, and this is the hypothesized, the tested value. Remember, that was the same value, and then we saw in the previous thing, and then this is S. Great job, 100 points right there. Keep it up. Good practice. And so we have, now we put in the notation into the equation. The sample mean of 7.5, the hypothesized mean of 10. So that'll be the difference, how far they are away. 6.5 divided by square root of 25 equals to negative 2.5 because we were below what we hypothesized. Square root of 25 is 5. That is 1.3. And you know what? Once again, this is one of those things we could solve in our head because this whole thing is equal to a t with how many degrees of freedom? We didn't mark the degrees of freedom. Who knows how many degrees of freedom this has? What are the degrees of freedom for? So the degrees of freedom here would be equal to what? So the t with a certain amount of degrees of freedom is equal to negative 2.5 over 1.3. So it's gonna be close to that. Gonna be close to that. So 2.5. No. Negative divided by 1.3. And there's that. So what are the degrees of freedom? If we were to finish off this problem here, which we're not required to, negative 1.92. That's the t statistic. And how many degrees of freedom does it have? So the degrees of freedom right here are n minus 1. And so the degrees of freedom would be, if the sample size is 25, the degrees of freedom would be 24 degrees of freedom. So we oftentimes put that as notation right here, 24 degrees of freedom. So the p-value, which we don't have to solve all this, but it's good practice. The p-value for this, and we've actually just run a full hypothesis test, the p-value for this is going to be very, very similar to what we just found. Oops. Oh, no, we're doing a less than test, right? We're concerned the claims are exaggerated, so we're doing a less than test. So the p-value here is going to be, I estimate it to be about 3%. About 3%. And let's go look at it on the t-applet to show how this would be solved using the t-applet. So this is the final solve right here. I estimate with what it wants the t statistic. It wants the t. So this is the test statistic right here. It says, what is the test statistic? So what is the test statistic? And this is the test statistic right here. So the test statistic is the standardized metric, and that is the test statistic of what it wants. It wants negative 1.92. It says, what is the test statistic? But if you finish off the test right here, you would take the test statistic, go to the t with 24 degrees of freedom, and do the less than test, and enter in your t statistic of negative 1.92, and we get a p-value of about 3%, which is very close to the whole z-score thing. T's and z's are very similar, but every t has with it degrees of freedom. You have to know the degrees of freedom to know which t you are using. And does this make sense here, Tiffany? So we did a whole big solve on this. We basically solved everything we could possibly solve for this question right here, worked it as a full problem, found the p-value. We could reject the null hypothesis at the 0.05 alpha level. So this is a good example of a full test question right here with like multiple parts. But the only thing it wants us to say right now is, what is the test statistic? So all we had to solve truthfully is this right here. Does that make sense? It just wants the test statistic. That could be, yep. And then that is as long as that's your answer right there, yep. So that is your test statistic. And where is the quiz? Negative 1.92. That's what we got right here, right? Yep. And so now it says a smaller p-value provides stronger evidence against the null hypothesis. How about great? Happy Tuesday. Awesome. Thank you so much, Colin, right there. So good to see you. 100 points, Colin, appearing. A smaller p-value provides stronger evidence against the null. That is very true. The lower the p-value, the more we're able to reject the null. We got to remove that. A type 2 error is, now repeat after me. In a type 1 error, the null is true, and we reject it. In a type 2 error, the null is false, and we fail to reject it. So if you see right here, here's the 2, and null is false, and we fail to reject it. Best way to memorize this: in a type 1, the null is true, and we reject it. In a type 2, the null is false, and we fail to reject it. So a type 2 error is when the null is false, and we fail to reject it. And there's the 2 F's of the type 2 error. The null is false, and we fail to reject it. Easy way to get the points on the test on that. So memorize that. Good way to go. True or false? A low p-value is evidence of a cause and effect. Yeah, I think we have enough time. We'll do it. We'll try, Michael. We'll get this. Got like 45 more minutes. We got this. A low p-value is evidence of a cause and effect relationship. Oh, I hope no one answers the wrong way on this one. Low p-values show cause and effects. What do you think? Low p-values show cause and effect relationships. Very, very what? P-values low, you say, cause and effect. False. False could be. No. Statistics can't talk about cause and effect. Statistics talks about just associations and what we would, it says cause. If it says cause, it's pretty much going to be wrong every time. Unless, which we don't cover in this class, it would be an experiment. Randomized controls experiments can give good evidence of cause and effect, but we don't cover experiments really. Experiments are great, but we're not doing that right now. Low p-value unless it's done via an experiment. So if you see the word cause, usually trying to trick you right there. Correlation is not causation. Everyone knows that. Not everyone. If you're taking the statistics class, you should know correlation is not causation. What is it when we reject the null and the null is true? Tell me. So remember, in a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. Yeah, definitely. We might have time. We got a lot of questions. Thank you to everyone showing up. A lot of questions. Next question comes from, we did organization monitors. Can we do a couple for chapter 15? We did. In the 1980s, it was generally believed congenital abnormalities. Then we got 320 coming up next. Congenital abnormalities one. Let's do the congenital abnormalities question. So, congenital abnormalities. Thank you so much. So many great questions right here. Congenital abnormalities question. Here we go. It might be. I can't confirm. Just practice. In a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. Just make sure to have that memorized. Just be like, type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. These are F's. These are T's. In a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. Best way to memorize it. Double check right there. Here we go. Congenital abnormalities question. Let's do it. In the 1980s, it was generally believed congenital abnormalities impacted 7% of children, and they're going to take a sample right here of 390 children. 48 of them have signs of congenital abnormalities. We're going to use an alpha level of 5% to reject the null, and now we need to start this off. We want to see if there's evidence that the risk has increased. Now, once again, what do we do whenever we start a question? We go to the notation, and I need your help. This is where the practice really comes into play right here. Can you mark all the notation? I'm going to start highlighting it for you. And then once you get in the theme of marking the notation, you can solve the problems. So who's going to help us off with marking some notation right here? That's usually the tough one. That 7% is usually the one people get wrong because that's the new one for this chapter. So what notation do we have? I'll write the equation for you. This is the equation we would use, which is going to give us hints on what we're going to be solving. You might be saying, how can we get, there's a bunch of things. P hat times Q hat over n square root. So this is going to equal to a z score. Michael, great job right there. Michael, 100 points. You got it as P naught. So 7% is P naught. That is the hypothesized. And if that's 7%, great job. Got the ball rolling right there. Nice and quick. Q naught is 0.93. Because it's the complement. So P naught and Q naught add up to 1. So we know what P naught is, which is the hypothesized proportion. We're saying, well, let's assume this is true. So you know what we could do right now? We could write out the null. The null hypothesis always has the equal sign, and we're asking, has the risk increased? Is there evidence? So the null hypothesis is that the true proportion is equal to whatever we hypothesize it to be. Now, in this one, we're asking, has the true proportion of children with congenital abnormalities increased? And, well, what is the null proportion? Well, the hypothesized null proportion, same thing, hypothesized null, is this. And we just wrote out the null and alternative. So the null says that it's still the same, like congenital abnormalities are still the same. We hypothesize that the null is true to start, that we're saying, well, congenital abnormalities were 7%, and now they're still 7%. The alternative is the true proportion of congenital abnormalities has increased from 7%. So we need to run a test right here to see if this difference we're looking at is either large or small. Michael got us on the right track right here. So this one's tricky because it gives you this. It gives you this. That's the number we sampled. So n, and this is x. So x over n equals, what does x over n equal? This is number of successes over number of trials. And that is going to equal to p hat. Great job, Michael, right there. Crushing it, man. More points in the chat. Great job, Michael. Michael solved it, saying 48 over 390. That's p hat. So nice number right there. 1231. So p hat, and we'll put p hat up here. P hat equals 0.1231. There we go. So now we need to write our equation. 0.1231 minus 0.07. That's how far it is away. The top part of this is just a difference. And then we're standardizing this difference, calling it a test statistic, to then run the test and see if there is a difference. And so this will give us the z-score right here. Got just enough room for that z-score. And so 0.7. Michael, great job today, man. Great job, everybody. Good practice. That's what I always hope, is that people can practice along, and like solving these helps show the methodology, and it really just comes down to practice. 4.11. I can tell you the p-value. 4.11. Now, this is where, once again, on a test, people say, well, how would I be tested on this? So on the test, if you get a z-score of 4.11, here's how the David M. Lane's going to look. The David M. Lane for this, it's going to look 1, 2, 3, 4. And so we landed right here at a z-score equal to 4.11. Now we're going to shade to the right of this because it points to the right. We did a greater than. The p-value is going to be very close to what, Michael? The p-value is going to be very close to what? Because I've drawn this too big. I've drawn it too large right now. The p-value is going to be very... Let me try. You ready? P-value is going to be very close to what? You should be able to estimate and be like, p-value is going to be close to this. And I think we'll be fine if we actually put in this number. The p-value is going to be very close to what? So we know what the z-score is, and we can plot it on the curve. This is what the David M. Lane would show us. So we do like, what would the David M. Lane show me? We're going to plot to the right of the z-score because the greater than points to the right. So you shade to the right side of it. And so the p-value could easily be estimated here to be this, which a test question could give you all options, and it'd be like, let's choose the one that's closest to this, if it gave you options. And so let's see what people think in the chat. Let's go answer the questions. And so we wrote out our null and alternative. 0.07 is the hypothesized. That's P naught, and that goes right here. We were testing to see if it's greater than. So the true proportion is equal to 7%. It's greater than. You're right, Michael. 100 points in the chat. It's going to be very, very small. Exactly. There are more than 10 successes, more than 10 failures. Success-failure condition. It was a random sample. Independence, because it's random. And less than 10% of the population was sampled. Good to go. It jumps right to that p-value. So I think we're good to put in 0. Unless I did something wrong mathematically, I think we're good to put in 0. So I guess I'll show it. It says how many decimals? 3 decimals. David M. Lane coming right up. Or I think we already have a David M. Lane up. Let's go to the above, and let's take our z-score. And above, and it's 0. It's so far off the curve, it's basically 0. So yeah. It's not exactly 0, but it's very small. You could say it's close to 0 at this point, because even to 4 decimal places, we get 0. David M. Lane goes to 4, I believe. Explain what the p-value means. It's the probability of observing what we saw. It's the probability of your results of observing the 48 congenital abnormalities in a sample of 390, given 7% as the truth. So what we saw right here is very unlikely. So this would be evidence to reject the null because this p-value is tiny. What we saw 48 congenital abnormalities. Assuming 7% is true is virtually impossible. Very hard for this to occur by random chance. So there's good evidence that it's increased. So I would reject the null and say there is evidence that it's increased. The only options we have here are reject the null, there is evidence, or fail to reject, there's not evidence. And we reject the null because, did they mention alpha? Our p-value is below the 5% rejection rate. So we reject the null here because the p-value is below alpha. If the p-value is lower than alpha, reject the null. If the p-value is high, just let it fly. Just let that null be. Do environmental changes cause? This is usually one that catches people. This cause right here is a trick word. Trying to catch you. It's unknown if it causes it. We can't say cause and effect. We can just say, because who knows what's changed? We don't know. This was not an experiment. This was just an observational study, and we've got 100%. And once again, I want to point out a lot of times the p-values here you can get a good guesstimate of. So when you think about how it could be on the test, the best thing to do is when you're practicing these, draw what you expect to see on the David M. Lane. We did all of our work here working the problem without really seeing the questions, going through the steps of writing the known alternative, solving for the z-score, solving for the p-value, and doing a drawing right here. When we went over to the David M. Lane, it's just going to find the exact value for us, and it's saying 0. It's so far off the curve that it really can't even see it. You don't really start to see p-values till about 3, and even then it's a little hard to see, and you can actually visually see the p-value. So my drawing right here, where I tried to make it so small we could barely see it, that little shading right there is the p-value. It's so small, it's about 0. And yeah, let's do some 320. Good practice right there. Excellent work. 320 question was, I think it's like the furniture stuff, right? Kevin says, do you think it'd help with the assignment, the interpretation of ad revenue predicting sales? Yeah, let's go check that out. Ad revenue predicting sales. Oh, I should mention this. One of my students emailed me inquiring. See right here. I'm doing that right. Nice. Yeah, Kevin, I saw your email right here. So awesome. I'll reply that here in a little bit. And great job, everybody. Lots of hard work. I realize, like, man, there's so many things going on, especially in the world or class and everything. Busy, busy, busy. We're all so busy, it seems. But we're about to winter break. Take a break for a month. Whole month. And then I'm doing winter mini-term. First time doing winter mini-term. It's going to be interesting. Wednesday. Oh, I'll mention this in class. So we did some regression. Okay. Ad revenue. Hey, Trevor. Good to see you here. Trevor, let's throw some 100 points in the chat. Okay, let's take a look at ad revenue. Where's the ad revenue? We're looking for the ad revenue. It says time at 9. I'm looking for the ad revenue, Kevin. Yeah, it's right here. Okay. Yep. Let's go take a look at some ad revenue on logistic regression. Not logistic. On indicator variables. Indicator variables 320. Let's go look at indicator variables. So this is just like jump output. So if you look at this right here, we have an estimate of a coefficient. We have our uncertainty in the estimate of the coefficient, the standard error. A t-statistic. This is actually a t-statistic right here, a t-value and a p-value. If you notice right here, the t values and the p values are inversely related. And you can see like our relationships like the 0.05 close to a t of 2. So, and this right here is the smallest t with the highest p value. This right here, we're looking at the revenue made based on different products. And the most significant thing accounting for the other variation is how many ads were taken out. So pretty simple to see that you make more revenue when you put more ads out. But the confusing thing, if you're in 320, is what's the deal with room, kitchen, room, office, size, small? Now, there's things we don't see in this output. We don't see room, bedroom. And why don't we see room, bedroom? Actually, maybe I should put dots for those. Why don't we see room, bedroom? That's such a good question for 320. Why don't we see room, bedroom? Why does room, bedroom? Because it's a reference all exactly. There is a room, bedroom that exists. And room, bedroom has no difference from itself. Room, bedroom has no difference from itself. So exactly, Kevin, 100 points is the reference level. So then there's another size right here that we don't see. And you don't have to do this to this output, but I'm hopefully showing people that there's things we don't see right here. And you know what we should do? We should put the reference level alphabetically, because this is how the reference level is chosen. We should put it alphabetically first. So LMNOP QRS, oops, size large. And we're going to take this right here. And it doesn't really have a coefficient. the reference levels don't have coefficients. And so size is the variable. So this is the variable name right here. Size is the variable. And then let's break this up a little bit by doing something like this right here, indicating that that is the level. So hopefully this makes a little more sense of this output if you look at it this way. Sure, we'll let that look like that. Does this help a little bit, Kevin, seeing it this way? That the variable is room and then the level is bedroom. Like, what room is the item being sold for? It's being sold for the bedroom. What room is the item being sold for? It's being sold for the kitchen. So I think it should be a pretty obvious now. It says right here, interpret the coefficient of adds. Let's take a look at this a little bit. Keep asking those questions, Kevin. You got it. The coefficient of adds is just a quantitative variable. Adds is how many adds were taken out. So when you look at this, I'm not going to write it down, but I'll say it. Two products that are otherwise identical. That means like they'd be for the same room, they'd be the same size. Like think about a large product that goes in the kitchen, refrigerator. Think about a small product that goes in the kitchen. That would be like a Keurig machine. Like, what is large? What is small? Well, it's like, you know, when you see it, large is a refrigerator, small is a can opener. Would I say two adds that would be otherwise identical? Yep, or two products because we're selling products, right? So in marketing, the relationship between the sales of a product, so two products that are otherwise identical, but differ in the amount of ads taken out by one ad, the product with more ads taken out is expected to have a higher revenue, or this is dollars in ads, right? Ads, thousands of dollars, the room. Okay, yeah, because this is how much we're making. So predicting the sales. So we're trying to explain sales and then ads in thousands of dollars. Yeah. So that is great job right there, Kevin. Kevin, you're doing it properly. Yep. I might just say this one. Two products that are otherwise identical but differ in $1,000. Finch, good to see you here. But differ in $1,000 in the amount of ads they have taken out. The product that has more ads taken out is expected to have higher sales by $969.43. I'm not going to write it down, but I'll say it. I'll repeat it again. Two products that are otherwise identical, but differ in the amount of ads taken out by $1,000. The product that has more ads taken out for it, or more amount of ads money spent on it, is expected to return back a higher sales amount by $969.43. So that means otherwise identical, like they're the same. It helps a lot. Awesome. Yeah. So if you're practicing writing it down, knowing how to do it for the test is very important right here. And the otherwise identical is super important because we're talking about, you know, they're the same. Like it's like two refrigerators. And we have two refrigerators where one has more ads taken out for it. We expect the refrigerator with more ads taken out for it to have a higher sales of $969.43. So pretty good right there. Now, what does room kitchen mean? Yeah. Here, I'll do one more for you. Great, Kevin. Thank you so much. Kevin, 100 points. So much positivity right there, figuring it out and coming with such a great question. And this will probably help a lot of people. Just do a little bit of the assignment right here. Nothing wrong with doing a little of the assignment. So jump in. Always ask the question. Be like, we'll work a little. Room kitchen is a what variable? So kitchen is a what? Like, I want that I word in the chat. Kitchen, you bet. Kitchen is a what variable? Like, you said bedroom was the reference. So references don't have coefficients. They don't have estimates. So room kitchen is a what variable? It kind of points and says, this is for the kitchen. That's a categorical variable. And there were 3 levels to this. It's an indicator. Exactly. So room kitchen is an indicator. Great job, Kevin, right there. It's an indicator. And so with it being an indicator, you would say, because it indicates something's for the kitchen. But you're going to then compare it to the reference, because think like in reference to the bedroom, room kitchen is expected to have lower revenue. So when we think about this right here, it'd be 2 products that are otherwise identical, but one product is for the kitchen and the other product is for the bedroom. The product that is for the kitchen is expected to have lower sales by $122.94. Now, this is in thousands of dollars, so I usually would just multiply right here to give context. Like, think about if you say to someone, it'll have lower sales by negative $1.2294 thousand. Someone's like, negative $1.2294 thousand. You just kind of convert it for the boss and be like, Well, we have two products that are otherwise identical, like they're the same size, and we take out the same ads on them. And the product that is for the kitchen is expected to have lower sales than the bedroom product by $122.94. So you would probably, you wouldn't say negative 122 point, negative, yeah. Try to make it make sense for somebody. And it's hard to write a static interpretation to use for everything because then it sounds too robotic at times. But like using our static interpretation, two products that are otherwise identical, but one product is for the bedroom and the other product that is for the kitchen. The product that is for the kitchen is expected to have lower sales by $122.94. Yeah, than the bedroom product. And that's because we compare the indicator to the reference because this negative is compared to the reference. And I think this basically got it. Figuring out the highest ones shouldn't be too bad because, you see some negative coefficients here. Writing out the zero kind of makes it more obvious which ones would have like the highest sales. But Kevin, great work. And yeah, I saw your email, so I think I kind of skimmed it. And I think good stuff right there with the email. Exactly. I think the rest of it should be obvious. So great work, Kevin. Good practice on indicator variables. And it might blow your mind, Stat 201, but these are categorical variables in a quantitative model. But it's not breaking the QQ straight enough, no outliers, because Kevin, last question here for 500 huge points. What are the only values that indicators can take on? Anytime, man. You got it in third. Let's get some 500 points for everyone watching. What are the only values indicators can take on? Because they are categorical, but they're indicators, and the only values they can take on are what or what. Because we're going to not break the QQ straight enough, no outliers, by making categoricals into indicators, and then they can only take on this value or this value when we solve the equation. Because we can use them as quantitative, kind of. We can trick the model into be like, well, these will be quantitative. They'll indicate whether or not. 0-1, Kevin, some big 500 points. Great job right here. Let's hop back to the main screen. Great answers, Kevin, right there. You got it. Indicators can only take on values of 0, 1 because it's like indicating. It's saying like this is the indicator level, and then 0 if it's not that level. And then if all the indicators are 0, we would solve out the reference level. It's exactly it. Wilson, great to see you here. We got everyone here. Everyone's here. I'm just having fun today. Let's just dab on these questions. Next question is... we did congenital abnormalities. Next question comes from... Going down the questions. Can we do the school dropout question? Riley said school dropout question, and then Tiffany's got the next question. School dropout question is next. I'm just like, let's just go crazy here. Go crazy, don't mind if I do. School dropout question. Here we go, school dropout question. Stat 201, let's go check it out. A nonprofit company even, is concerned about school dropout rates. They've designed a tutoring program to take a look at this, and they saw the dropout rate was 9.5% in previous years, so that's kind of like a starting off point. And one district that did this found out that 158 dropped out of the 1764. It's tough. I know people who've dropped out of high school. I don't know. It's a lot of like life circumstance stuff. It's a lot of family and support structure. Like it's tough because it's, I don't know, if you got that support grid, kind of helps out with not having these things, but nothing's promised. But it's tough. So we have right here 9.5. We have here, this is the amount out of the sample. Can anyone help us off with any of this notation as we write the equations? So here's the equation we're going to use to find the z statistic. What do we have? We have the sample proportion minus the hypothesized true proportion over the hypothesized true proportion times the complement of the hypothesized true proportion over the sample size. So you might be saying, how will I get all of this out of this? Well, 9.5 is what it was in years past. So we might hypothesize that that's true. 158 is how many we observe out of a sample of 1764. And so we want to know if this has been effective. So asking if something has been effective would mean that we would take right here the null hypothesis that the true proportion of students who drop out has stayed the same of what it currently was. And if it's effective, we should say the true proportion has decreased right here. We're trying to lower high school dropout rates. So whatever you put right here in this spot, this is P equals P naught. P, the true proportion, is equal to something we hypothesize it to be. So with us hypothesizing something, well, over here, this is going to be the hypothesized proportion. This is the number of successes out of the number of samples. Successes just means things we observe that conform to what we're asking of the question. It's not a success to drop out of school. I don't know, craziness, sociological stuff. And let's go here. X over N equals, and 158 over 1764. This is going to equal P hat, which is the sample proportion. And 158 divided by 1764. And there it is. Ooh, it's kind of close. It's a little bit lower, which we want to see. 0.089569. I think that was right? 89569. Oh, percent. And that is the sample proportion. So now we're just going to take and solve the equation. And the equation right here, let's take the p hat of 0.089569 minus p naught. And 0.095 times 0.905. And take the sample size of 1764. And there we go right there. And so let's solve that z-score. And so let's take the bottom of the equation. There we go, square root it. And so there we are with the numbers right there. And there's the z-score. So we just solved that equation. Now, this one is a little bit harder to guess p-values on, but I'll draw it out for you. Remember, we always draw these out to see how the p-value looks, and it's going to be negative 0.778. So can we move these over? We'll write the z-score. And this right here is going to not be the smallest of p-values. This is a very hard one to guess, but we could get close. A little further than that. Oh, really? And we'll put the z-score right here. And then which way will I shade? To the left, to the right, or both sides of this? So which way will I shade this? To the left, to the right, or both sides of it? Which way will I shade on this curve? To the left, or to the right, or both sides of the z-score? So this is the z-score right here. And which way will I shade the curve now? This is where mistakes often happen. We're asking, has this been effective? And so will I shade to the left, to the right, or both sides of this? It's a very hard p-value to guess. We know it has to be greater than 16% because below here is 16%. That's kind of an answer. So we are going to shade to the left of it. Reason being is because we are doing the less than test. And so we're going to shade to the left of it. And it's going to be about, it's got to be between 16 and 25 because I know where 25% is from z-scores. I would say this is about 20%. We're going to go here to the David M. Lane applet. I say it's about 20%. How close is our guess today? We go in here and we shade below a z-score of the following. And I say 20, it's 21.8%, 21.83%. So close-ish. And then if you look at our drawing, this is what you want to practice and be able to do, is you want to be able to make drawings that look kind of like what you get. So you want to be able to say, okay, here's my drawing of it, and my drawing should look kind of close to it. I didn't draw the curve, peek it enough, but we kind of got a good drawing close to it. And that's a pretty high p-value, which means we're not going to reject the null. So now we just have to go through here and mark our answers for what we did for the problem. We have right here that we are testing to see if it's equal to this or if it's decreased. The null has the equal sign, so we can narrow down a lot of choices. The test statistic is going to be the z-score we found right here. So let's go ahead and bring it down to the test statistic, down to 2 decimal places. The p-value, it should, 4 decimal places. I'm going to recalculate the p-value because since it's having me round that, I want to put in this right here. And, okay, it should give me that if I put in the other one. That would be very, very hard to guess. And so has it been effective? Right here, it looks like what we're seeing could be by random chance. So the school's dropout rate would not be unusual if the national statistic rate was still 9.5. It would not be unusual, correct. Yeah, we conclude it's not been effective because what we're seeing right here seems, they say, oh yes, we improved. We lowered the dropout rate. The dropout rate is now 8.9%. And you're like, well, that is lower, but it's likely by random chance if it hasn't changed. Like, given it's still 9.5%, you could see about 8.9%. Like, this is possible, very likely by random chance. So I don't think it's been effective. We don't have good evidence of it being effective. We don't see enough of a decrease to think that it really has changed. It could just be that maybe just randomly we had less people drop out in this sample. I think we should have everything right here. Woo, a little bit scared there. Also a little bit scared. A little scared helps. That's got it. Let's go back and do another question. I think we have next question from Tiffany. Let's go check it out. Next question is... Go and find it right now. Tiffany says, the data from the sugar content one is, I believe, yep. So, I think that's the next one, right? I'm double checking to make sure we're doing them in order right here. I think it is. Let's go do the sugar content. Awesome. Let's go do sugar content from adult and children's cereals. Sugar content. Adult and children's cereals. Chapter 17, sugar content. This one is a jump one. My Pearson wants me to sign in. My Pearson, what are you doing to me? I'm going to get jump loaded up here in the background. I've been trying to re-download jump 16, but it's like, nope. No jump 16 for you. You have to use jump 15. Jump 15 loading up in the background. So this one is very good for us knowing how to read output from models. I keep waiting for those Black Friday, whatchamacallit, video game deals. Not the candy bar, whatchamacallit. I am so excited for new video games, except I've been playing Isaac by Ed McMillan. I think that's how you say his last name. Great game there, The Binding of Isaac. Such a good game. Too addictive. Every once in a while, I'll play a run at night. Big fan of Isaac and Gungeon and Slay the Spire. Oh, there's the sugar content. We got this. Let's go check this out. What's your favorite video games? Well, I need jump for this problem. You will need jump. Well, you can do it without jump, but I would use jump for this problem. Sugar content of cereals for adult and children. Let's check out a jump problem right here. Here we go. This is going to be way easier with jump. Way easier with jump. So if you don't have jump on your computer, make sure to open up jump because solving this one by hand would be not fun. So this problem right here is a really good understanding how to read jump output, which could be on the test. So let's go ahead and do the steps right here. So follow along. We're going to open up right here and go to copy to clipboard. I'll pause on each step. So we're going to copy the data to the clipboard. Just opens up a clipboard. Boop. And then we're going to hit Control-C or Command-C. On a PC, hit Control-C. On a Mac, hit Command-C. And so now the data's been copied. We'll just pause right here. With the data copied, it's just in the brain of the computer at the current moment. And now that we've it copied, it's floating here in the background. We're going to go over to Jump, and we're going to go to File, New Data Table. In Jump with File, New Data Table, this is where we're going to paste the data into, and we'll have the data pasted into Jump. So here we are with File, New Data Table. Boop. And so for this one, open on the other page. For this, don't click inside of it yet. Don't click inside of it. Go to Edit, Paste with Column Names. Edit Paste with Column Names is required because there is a column name for child cereal and a column name for adult cereal. So make sure to paste with column names. Very important right there. Paste with the column names. Remember, File, New Data Table. Paste with the column names. Boop. If these are blue, you've done it properly. I think so. Yep. Martha, if you can't find it, let me know. But we should have one with the philanthropic. I think we did it during class, and we did it during yesterday's office hours, I think, and we've labeled it with these awesome. Great job, Tiffany. So it should look blue. If it looks blue, you're fine. If it looks red, there's an error. I'm going to look at one thing. I want to see something. I want to see if there's an alternative way for me to solve this problem. I'm trying to see something. I know how to solve it, but I'm seeing something. Yeah, it doesn't like that. I'm seeing if there's a way. Yeah. I think you have to do what we need to. We're going to stack it. I was just thinking if there was an alternative way to solve it. I was like, is there a quicker way? Is there a way to skip that step? Unless, pause for, I just want to see if this will work. I don't think it has a way of running the test on this. No, you can't run it here. Okay. Oh yeah, let's do the next step. There's no way to skip this next step. I was trying to see if we could. We want to go here to tables and stack. Tables and stack. I guess that's not hard to do it. We're going to go here to tables and stack. With tables and stack, we're going to take both of these columns right here and stack them on top of each other. So we're going to make one column out of this, and then there's going to be a column for adult or children's cereal. All you're going to do right here is double-click children's cereal, double-click adult cereal, and now you'll stack it. You could rename the table, all that stuff, but we're just taking the columns and stacking them on top of each other. And you'll see right here, these two columns will be stacked. And there you go. So we now have the tables, we have the data stacked right here, and we have a categorical variable for the label for the cereal, and we have the data itself for how many grams of sugar there are. So now that we have the data looking like this, remember tables stack, double-click both of them, and it stacks those columns on top of each other. So now we have a categorical X and a quantitative Y. So we can look at the mean for children's cereal and the mean for adult cereal by going to Analyze and then Fit Y by X. Analyze Fit Y by X is going to see if some X variable like label explains the variation in the data, which will be a quantitative Y in this instance. So we're going to compare the means for the mean content of children's cereal versus the mean content of adult cereal for sugar content. So let's see if the label, which is the X, the label of the cereal, explains why we have a certain sugar content. So label is the explanatory variable. Does label explain why there is a certain sugar content? Let's go and click OK. And here's the output. Looks pretty obvious that adult cereal has way less sugar than children's cereal. You can even do this right here because you can't have negative sugar content. We're going to go here and go to the t-test, and this will run the full test for us. From here, we just have to look at, oh, Loa Ditto, good to see you here. From here, we just have to look at the output after going to the red arrow and going to t-test. So now that we're on the t-test, we can see the difference between the two means. The difference between the two means was 35.26, 35.3267. And that's if we look at the average for adults and the average for children, there'd be a difference here between 32. And it says children minus adults. So the mean for children was higher because when you look at children minus adult, children has a higher mean. You can see it right here. The mean would be up here somewhere, and the adult mean would be down here at the center of that data. The t ratio right here is literally the difference divided by the standard error. So this difference right here is 35.326 divided by 2.16. And is this difference statistically significant? Most definitely it's statistically significant with a t of 16.33 and degrees of freedom of 44, which tells us which t we are using. We have extreme statistical significance to say there is a difference. Also, we have evidence that children's cereal has more sugar content. Yeah, ask away. Yeah, we probably have a moment here. And then we are 95% confident the true difference is somewhere between children's cereal having between about 31 more grams of sugar to about 40 more grams of sugar. And look, 35 is in the middle. Margin of error of 4.4% or so, plus or minus 4.4%, 35.3 plus or minus 4.4% is how the interval would be written. Knowing this output is very important. And the output has all the answers we need. So let's go look at this output right here. and the confidence interval. So we should be able to get it both on the screen. There we go. Let me disappear. The confidence interval goes from a lower bound of 30.97 to an upper bound of 39.69. I think that's right. Hopefully I copied it correctly. Interpret the confidence interval based on these samples with 95% confidence. Adult cereals on average, the adult cereal average between the lower and upper bound more grams. No. Based on these samples with 95% confidence, children's cereals average between the lower and upper more sugar than the adult cereals. So 2 decimals again right here, and just knowing how to get the output and knowing how to read this, and we should get it right there. So once again, this is our confidence interval for the difference between the two cereals. We are pretty confident, very confident, that children's cereal has more sugar than adult cereals. This was the most sugary adult cereal. This was the least sugary children's cereal. And you can see sugary children's cereals are definitely more sugary. Someone just wanted cereal on this. And that's got it. Good question right here. And knowing how to read this output is key, though. Knowing that it has statistical tests and confidence intervals to find out the difference between the two means right here, getting the answer. But it's mainly like, do you know how to read jump output and get the answers? Because solving this by hand would take way longer to solve, like to get the mean, the standard deviation, to run the t statistic. But statistical software makes this way easier to solve. It's got it. What questions are there? I think we have one more, and then we got class in 20 minutes. 20 minutes to class. So let's see. Might have to send some people. Trying to see. I thought there was one more question. The philanthropy. Check out the philanthropy. Yeah. Oh, Diddle. I'm gonna head off because we got 3:20 coming up here in 22 minutes. So I'm gonna grab a little bit of lunch too. Got to grab some lunch. Oh man, lunchtime. So, Ditto, send me the question on Discord. I got 5 things on Discord right now. I'll be checking out Discord. I'm probably gonna head off here so I can grab a little bit of lunch. And I need to send out the reminder to 3:20 to join up class. Send me the question. So type it up. Send it on Discord. We'll take a look. Good work on 475. You got this. We'll be back. Puppet Shark, you good, man? He's good. He's always good. We'll be back here a little bit later. I'm like, it's no? We have afternoon officers coming up. What day is it? Don't lose your mind. We'll be back here a little bit later. I'll see everyone then. Swing by for afternoon office hours. Bye for now. Thank you so much, Ditto. Bye for now.